subscribe the channel and press the bell icon.
Hey guys, welcome back to another video. I'm Danmani. Today I'm gonna solve a problem which has come in the year of 2014 in Guwahati University 6th semester examination. So here is the question. Explain why X-rays can get diffracted from solids. Illustrate quantitatively how Bragg's law can be used for determination of lattice constant. It was come in the year of 2014. Before we go to the video, first of all we have to know the Bragg's law. So basically the Bragg's law is the path difference is an integral multiple of wavelength, that is twice the sine theta is equal to n lambda. So here is the schematic diagram of Bragg's law. You can see light from the source is coming and which is hitting at the point O of a crystal plane, and it got reflected by making an angle theta. So basically I'm trying to show two ray diagrams so that you can easily understand about this figure. To obtain the Bragg's equation from this figure, we are considering the triangle OAB. First of all, here the interplanar spacing is d. You can see from the figure. So from triangle OAB, that is sine theta is equal to AB by OB, which is just a normal trigonometry. So sine theta is equal to AB by D because OB is equal to D, and from that we get AB is equal to D sine theta. Similarly, for triangle OBC, BC is equal to D sine theta. The similar trigonometric equation, and here the path difference is equal to AB plus BC. So from figure and from the equations, AB plus BC is equal to twice D sine theta. So path difference, that is equal to twice D sine theta. That is the way to get the Bragg's equation from the figure itself. Now moving to the main question, the first answer, that is why we are using X-ray for diffraction. That is, X-rays are used in produce the diffraction pattern because their wavelengths are similar to that of interplanar spacing d, that is d, of solids. So you can understand that the wavelength of X-ray are similar to the interplanar spacing of d, that is 1 to 100 angstrom. Now moving to the other part, as we all know, that is from Bragg's equation, twice d sine theta is equal to n lambda, where d is your interplanar spacing, lambda is the wavelength of X-ray, and theta is the Bragg's angle, which you can understand from the figure itself. So from where we get d is equal to n lambda by twice sine theta. Now for the first order refraction, where in first order that is n is equal to 1, you can calculate that d is equal to lambda by twice d sine theta. Now I am going to solve for only for the cubic lattice, and that is DHKL. As you know, HKL is the Miller indices. If you don't know about Miller indices, if you have any query, then please comments below so that I will upload another dedicated video about that. From that Miller indices, D is equal to A by root over H square plus K square plus L square. That is a direct formula actually, and which we can calculate from the geometry itself, where A is your lattice constant and HKL is your Miller indices. So this way we can calculate A, which is your actually the lattice constant, and here the question asks you that you have to calculate the lattice constant. So this way, by knowing the Miller indices, we can calculate the lattice parameter or lattice constant. That is the solution for your question.